I have the pleasure of moderating the second TMT competition. As you can see, this is one of the most interesting aspects of this symposium, and I'm very glad to, first of all, introduce the judges for this particular session, which is the theme is health and aging. The first judge is Marguerite de Lambe, Director, International Affairs, Utrecht University. Babat Javed, Professor at the Center for Infectious Diseases Research, Tsinghua University School of Medicine. Shandor Kovac, Professor of Medicine and of Cell Biology and Physiology, Adjunct Professor of Physics and Biomedical Engineering, Washington University at St. Louis. Vibha Singh, a doctoral scholar at the School of Social Work, Tata Institute of Social Sciences in Mumbai. Ali Tekcan, Professor in the Department of Psychology and Provost, Boğaziçi University, Turkey. I hope I pronounced everybody's names correct. The criteria for judgment, I can just repeat again. Two criteria, comprehension and content, and engagement and communication. And as we saw in the first round, the public, the audience here also has the opportunity to give their own votes, which will vote to determine the People's Choice winner. So with that, let me open the competition. There are finalists. The first finalist is Mohua Das, National University of Singapore, and the title of her presentation is Light Up Fatso. Please, the stage is yours.
Hello. Growing up as a skinny kid, me and my body weight, we had a one-sided love story. I always tried to gain it, and it always kept losing me. The struggle was real. Today, obesity is a global health issue and a leading cause of diabetes, heart and liver disease, and cancer. But I totally understand how misunderstood a concept obesity is. Just blaming individual lifestyle or food habits is not always going to solve this public challenge. So what do you think? Can eating less and exercising more always help us tackle obesity? Well, let's see, because today my story is about a gene that can take a bad form in your body and control your appetite and metabolism and make you obese even if you intake the same amount of calories like any lean person. This gene, ladies and gentlemen, is FTO, stands for Fat, Mass and Obesity Associated Gene. It makes a protein called FTO, earlier known as FATSO. FATSO so far remains the strongest genetic link ever associated with obesity. But the first challenge we face is to study and understand FATSO more. To help with that challenge, in our lab, we have devised a simple technique to track FATSO inside cells. To understand this, imagine the genetic environment of our body. Visualize your RNA, which is basically your DNA minus one strand, as an intertwined structure. FATSO basically removes chemical marks or methyl mark from our RNA. After it removes the methyl marks, we observe that the small marks can actually alter the shape of the RNA. So when this mark is present, the RNA exists like a hairpin, forming a loop in that region. And once it's removed, the RNA changes to a duplex structure. Based on this finding, we designed the RNA in our lab that contains a methyl mark and an extra fluorescent molecule. We hypothesized that when FATSO removes this methyl mark, the RNA might change shape and activate the fluorescent molecule, causing it to glow. And eureka! When these designed RNAs were injected inside cells, we actually saw them light up, which was an indication of the onset of action of FATSO. This is the first time anyone could ever perform a real-time monitoring of FATSO inside cells. With this research, we hope to target FATSO in the near future to treat obesity from its genetic root. But for the time being, I have a simple message to all of you out there. Please do not blame yourself or that large piece of cake you're eating if you're getting fat, because now you know who's the real FATSO.
Okay, so thank you for that. The next presenter is Abhilasha Kumar from the Washington University in St. Louis. The title is That Word at the Tip of Your Tongue. Please, the stage is yours.
Imagine the situation where you're trying to think of a word or name that feels at the tip of your tongue, but is just out of reach. This process of word retrieval feels effortless and automatic in most situations, but it actually involves several moving parts. First, you have to isolate the meaning of the word, and in doing so, other competing words might pop into your mind. Next, you need to access its structural form through morphology and syntax. And finally, you need the sounds that make up the word through its phonemes. Failure to access semantics, morphology, or phonology can impair your successful production of the word. Such word retrieval difficulties are not only common among healthy young adults, but in fact, they substantially increase in older adulthood and patients of dementia. Understanding the mechanisms underlying word retrieval failures is the focus of my research. In my lab, we study word retrieval by presenting young and older adults with difficult word descriptions, and as they attempt to retrieve answers to these definitions, we present them with cues related in sound or meaning to the correct answer. So for example, if I ask you what the capital of Finland is, I might tell you that it sounds like Helen or that it is not Budapest. My research shows that presenting sound cues at the time of retrieval, like Helen, helps both younger and older adults remember that the answer is Helsinki. Providing meaning cues like Budapest is not helpful, as it introduces competition into the system. Moreover, older adults are more likely to hold on to this meaning information, which prevents them from moving on to new tasks. In my research, I've also differentiated between simply presenting these cues versus having participants produce these cues. Because in real-life situations, when you're coming up with a word, you often produce alternate words. My research shows that production of these alternate words, in fact, inhibits subsequent retrieval. So, is it all bad news? As it turns out, there is some evidence that this interference from alternate words is short-lived and cumulative. So, the more words you retrieve in succession, the larger the interference effect. In our lab, our future studies are designed to find strategies that reduce this interference effect. For instance, what happens when I interrupt your memory search with a task that's completely unrelated? Are you more likely to retrieve the intended word later? Does the type of intended word or alternate word impact this interference? We all know that forgetting names is the most common cognitive complaint among older adults, and this research is going to be promising in finding solutions to such word retrieval failures. So the next time you're struggling to come up with a word, taking a step back and coming to it later might be more helpful than producing alternate words that block your retrieval process. Thank you.
Okay, thank you, Abhilasha. And the next presenter is Chris McMillan from the University of Queensland with the title Clamping Down on the Flavors of Flu. Okay, good connection with the previous.
Let me ask you a question. What do noise-cancelling headphones, neck pillows, and the flu have in common? Well, these are all things that a lot of people like to bring with them onto planes, or at least that's what my experience was like a few years ago. I remember getting onto a plane and being seated next to someone who very clearly had the flu. After spending the next few hours sitting next to this person, I got off the plane and spent the next few weeks sick in bed with the flu myself. This virus had me aching all over, running a really high fever, and generally feeling, and if I'm being honest, probably looking like I'd been run over by a bus. The worst part was that I actually got my flu shot that year. Luckily for me though, my encounter with the flu wasn't all bad. When I went to the doctors, they felt so sorry for me that they gave me a lollipop, which was great. But for hundreds of thousands of people around the world every year, a brush with the flu will end in hospitalization or even death. And current flu vaccines are simply not doing a good enough job to stop this. There are many reasons for this. See, it turns out that current flu vaccines are based on a protein that sticks out from the surface of the virus called hemagglutinin. And funnily enough, this protein is a little bit similar to the lollipop that my doctor gave me that year. The head of the protein, which is furthest away from the virus, can change a lot, and be lots of different flavors, or what we call strains of flu, just like a lollipop can be lots of different flavors. The stem of the protein is a lot like the lollipop stick. All the different flavors or strains of flu all have a stick, and they all pretty much look the same. The flu is a clever virus though, and throughout the year it changes flavour naturally through evolution from, say, banana to chocolate nut flavour. But because of the way current flu vaccines are made, they only teach your body to recognise the head of the protein, or the lollipop flavour. This means that if you happen to get infected with a flavour that's slightly different to what you've been vaccinated against, your body can't recognise any other parts of the virus to kill it, and you still get sick. This is why you have to go to the doctors every year and get a new flu vaccine. In my PhD, I want to stop this. I want to create a universal flu vaccine that protects against all the flavours of the flu. To do this, we have found a new way using a novel molecular clamp to stabilise hemagglutinin. We have shown this molecular clamp allows us to make hemagglutinin both the head of the protein and the stem of the protein intact, which is unlike current vaccines where only the head is intact. So now, when we use this protein as the vaccine, we can get your bodies to recognise the lollipop stick. That way, it doesn't matter what flavour you get infected with, your body can still recognise the stick, kill the virus, and stop you getting sick. I really hope that this molecular clamp technology can help us stop these annoying yearly flu vaccines and help us really clamp down on the many flavours of the flu. Thank you very much.
That was Chris connecting to the previous panel actually. The fourth presenter is Jasmeen Sethi from the University of Hong Kong, and her presentation is titled The Ovarian Cancer Games, Catching NHF 1-beta Targets. Please come to the stage.
One of the very hot topics in our daily global dialogues is cancer, which is due to the building blocks of your body, yourself, growing out of control. Now, the golden standard to treating cancer is surgery, radiotherapy, and chemotherapy. However, there's one particular type of ovarian cancer, known as ovarian clear cell carcinoma, that is particularly resistant to chemotherapy. So, you know how the media has instilled this idea that if you move to a greener, a less polluted city, adhere to a healthier lifestyle, it'll just solve it all? Well, studies have shown that's not really the case, because this type of cancer occurs at double the incident rate in Asian women compared to Caucasians or Africans. Now, I'm Asian, and I'm close to my 30s. Just the idea of something unknown, something nasty, growing out of control, and the solution to treat it is really unclear, that's really scary. And so this is what piques my interest into this type of cancer, because there has to be a genetic mechanism that comes into play. Ovarian clear cell carcinoma consistently expresses a molecule called hepatocyte nuclear factor 1 beta, so HNF1 beta. Now, this molecule is not easy to target with a drug. However, just as an arrow hits an archery target depending on the direction of travel, similarly, HNF1 beta controls other genes and governs them by binding to certain parts of the DNA. And so this is where my research kicks in. If you cannot target HNF1 beta, what are the other molecules implicated in this type of cancer that you can be targeting? And to do that, we employed sequencing methods. And so this allowed us to read and study the changes that have occurred at the DNA level due to this increased expression. So essentially what we're doing is just catching all these HNF1 beta targets. This allowed us to get a short list of genes. There are about 124 genes involved in the cell growth, metabolism, and death involved in this cancer. And in particular, though, what was of interest was that HNF1 beta increased another molecule called fibroblast growth factor receptor 1, FGFR1. This was the most exciting part of the research, because FGFR1 is such a well-studied molecule that others have already developed drugs targeting FGFR1 in other malignancies. Hence, we didn't have to start from scratch. Instead, we focused our energies to see whether this type of drug would be effective in our type of cancer. And so, we used this drug in our panel of ovarian cancer cells and found that it indeed targets FGFR1. And as you can see from the image over here, you've got a group of healthy group of cancer cells, healthy. And then once you administer the drug, they shrivel up and form these dead structures. And so now, collectively,
Okay, so that was Jasmeen, and we come to the last presenter, that is Dalit Arshid, Interdisciplinary Center, Azliya. Please come onto the stage. The title is Living Long, Living Well, the Role of Pupillometry.
In the Jewish tradition, it is a custom to wish a person on their birthday may you live until 120. If birthday wishes teach us anything about human culture, longevity appears to be universally valued. Today, we're closer than ever before in human history to the day when living to be 120 is a fact of life, and we might need to find a new birthday blessing. Throughout the ages, human lifespan remained relatively steady at around 30, but in the last century, it spiked to 80. But what about healthy life expectancy? In the little time of 100 years, research as well as human society did not have enough time to adapt to our newfound longevity. This means that not only are we facing familiar age-related changes for longer, but we're also facing completely new changes. This means that many of them remain unresolved. One of the most common problems is hearing loss. It affects 2/3 of adults aged 70 and above, which will soon make up 22% of our population. Hearing loss may impede speech recognition. This means that it can interfere with our ability to hold conversations, a basic means of human interaction. But we see that even if speech recognition remains unaffected, hearing impaired older adults still experience fatigue when following speech, and that is especially true in noisy environments like a cafe or a lunch at a symposium. So why is that? Well, even if participants appear to perform at the same level, the amount of effort that is required of them differs. The notion that we exert mental effort to follow and listen to speech is called listening effort. And in the hearing impaired, it can become so costly that it can result in daily mental fatigue. Now, what we see is that in our study, in our study, we present older and younger adults with spoken words and a background of noise. We see that even if their accuracy levels appear to be similar, older adults have much larger pupil sizes. Now, we see that with pupillometry, we can see effort. So the larger the pupil size, the greater the effort, and vice versa. Now, if older adults have larger pupil sizes compared to younger adults, but perform similarly, this means that they need to exert much more effort to perform at the same level. Doing this on a daily basis can account for the fatigue that they sense. This is especially important because we're looking at a growing population of our society with unanswered health problems. This is why it's important to continue this research. We believe that we should value living well as much as we do living long, and we believe that if we use our resources and our research well, we could provide and not just wish for both. Thank you.
So we just heard 5 finalists, young, bright researchers. While the judges do their task, I invite all those present in the audience to also exercise your right to vote. And please remember that the judges will be announcing the grand prize winner, while you will be announcing the People's Choice winner. Thank you all for being here in this second round of the competition, TNT competition.